guys, I've got some more surd fun for you in this video. In particular, we're going to be looking at applications of surds in area and perimeter questions. And our very first question is going to be about pizza, because why not? Pizza is awesome. So let's say that we're given a pizza and we're told that its total area up on top is 200 centimeters squared, and we want to work out the exact value of its radius. So remember, when we're asked to work out exact values, we're either leaving them in terms of surds or we're leaving them in terms of their symbols. So like pi, for example. We're not turning them into decimals. So, what do we know about the area of a circle? Well, we know the formula for it. We know that area is equal to pi times the radius squared. So that's definitely going to be useful to us. Now we're being asked to find the exact value of the radius. So what I would do, before putting in any numbers, I would rejig that formula to make r the subject. So if we first of all divide by pi, we would get the area divided by pi is equal to the radius squared. And then if we square root both sides, that's going to tell us that r is equal to the square root of the area divided by pi, which by our rules of surds, we can write as root a over root pi. So now we've got a formula allowing us to work out r is equal to root a over root pi. Now we know the area is 200, so we're going to need to square root 200. So let's just play with that separately on its own a second. So if we want to simplify root 200, let's think of a square number that goes into 200, which would be 100. So we can write root 200 as root 100 times root 2. Now root 100 is 10, so we're going to get 10 root 2. So that's what we get when we square root 200, when we simplify root 200. Now if we put it all together, if we substitute that into our formula for r, we're going to get then that r is equal to 10 root 2 over root pi centimeters. There is the exact radius of our pizza. Cool. Question 2. So here we want to work out the area and perimeter of this rectangle and give our answers in their simplest exact form. So you might notice here that neither length has a particular unit attached to it. So we would just say here we've got a length of 6 plus root 3 units and a height of root 3 units. So my first job here would be to fill in the blank sides of the rectangle. So we know in a rectangle opposite sides are equal to each other. Okay, so let's have a look at the perimeter first. So we get the perimeter by adding all four sides together. So we've got a root 3, add 6, add root 3, add another root 3, add another 6, add root 3. Now if we simplify that as much as possible, we've got 6 add 6, which will give us 12. And then we've got root 3, add root 3, add root 3, add root 3. So we've got 4 root 3. So the perimeter is 12 plus 4 root 3 units. Now for the area, well, for the area of a rectangle, we multiply the base by the height. So we're going to do root 3 multiplied by 6 plus root 3, and that's going to give us 6 root 3 root 3 times root 3 is 3. So the area is going to be 6 root 3 add 3 square units. Rocking. Job done. Okay, question 3. So here we have an isosceles triangle and we're told that it has an area of 4 square units. And our mission is to find an expression for its perimeter. So at first glance, this might seem quite simple. We've got a triangle, we know its area, and we want to find its perimeter. It's not as simple as it may seem though. The reason being that to start off with, we don't know a single one of its lengths. So, it's very important that the triangle is isosceles. The property of an isosceles is that 2 lengths are the same size. So, that's going to be the 2 shortest sides. So if we start off by calling both of those sides A, then we know that the area of a triangle, so the area of a triangle is equal to the base times the height divided by 2. So here, if we work out the area using our A's, we're going to get A times A, which is A squared, divided by 2. So algebraically, our isosceles triangle has an area of A squared over 2. Numerically, we know that the area is 4. So what we do now, we set our algebraic area equal to the numeric area. So A squared over 2 is equal to 4. Now if we multiply by 2, that will tell us that A squared equals 8. And then, to work out what A is, we square root. And that would tell us that A is equal to root 8, which is equal to 2 root 2. So now we know, with our triangle, that the A lengths are actually now 2 root 2. So if we write those on our triangle, we've got a length down here of 2 root 2 and a length over here of 2 root 2. So now we know 2/3 of our answer because we want the perimeter of this triangle. All that we need to do now is work out the length of the hypotenuse. So if I just get myself some space, we're going to use Pythagoras to do this because we're dealing with a right angled triangle. Okay, so by Pythagoras we know that the short side squared and added together will give us the long side squared. So if we call this chap C for now, then we know that 2 root 2 squared add 2 root 2 squared will give us C squared. Now we actually know what 2 root 2 squared is because we just got that from square rooting 8. So each of these 2 root 2 squareds is going to be 8. So we've got 8 plus 8 equals C squared. Now 8 plus 8 is 16. So we've got 16 equals C squared. So if we square root that, that will tell us that C is equal to 4. So now we know all 3 lengths of our triangle. So this is now not C, this is now 4. So now we know the perimeter is going to be 2 root 2 add 2 root 2 add 4. So the perimeter of our triangle is going to be 4 root 2 add 4. That's the perimeter of our isosceles triangle. Cool. Okay, question 4. So here we have another triangle. This time our mission is to work out the area and the perimeter. So I would say here it's easier to work out the area. So let's do the area first. So area of a triangle is base times height divided by 2. So here we get root 3, root 2, all over 2. And then the only thing that we can do to simplify that is to combine the surds on the top. So root 3, root 2 would give us root 6. So the area of our triangle here is root 6 over 2 square units. Now as for the perimeter, we're going to need to play Pythagoras. So if we call this side A, this side B, this side C, remember Pythagoras tells us that A squared plus B squared is equal to C squared. So in other words, root 2 squared add root 3 squared will give us C squared. Now root 2 squared is 2, root 3 squared is 3, so we've got 2 plus 3 is equal to C squared. Now 2 plus 3 on a good day is 5, so that would then tell us that C is equal to root 5. So we can now work out the perimeter of our triangle here. The perimeter will equal root 2 add root 3 add root 5, and there's nothing else we can do to that expression to simplify it. Remember, you can't add or subtract surds if they've got different numbers underneath the sign. Jobs are good 'em. Guys, the last example for this video. Here we want to find the area of a square whose diagonal is root 2 units long. So on my diagram here, my green line is my diagonal, so we know that that's root 2 units long. Now then, what makes a square a square? Well, every angle is a right angle, but more importantly for us here, every side is the same length. So that means when we cut a square in half by its diagonal, then either underneath or above the diagonal, we are left with an isosceles triangle. So if we call both of these lengths A, we can do that because we know they're exactly the same length. Then we can play Pythagoras inside of this right angle triangle. So Pythagoras would tell us that A squared plus A squared is equal to root 2 squared. Now root 2 squared is 2. So A squared plus A squared will give us 2. A squared is equal to 2. Then if we divide by 2, A squared is equal to 1. Now that there has actually given us the area of our square. Remember, to work out the area of a square, you do the base times the height, which here would be A times A, which would be A squared. A squared equals 1. The area of the square is 1 square unit. Jobs are good, and guys, hope it's been useful.